All right, we're going to kind of go over yesterday's notes again for anybody that missed it or just really loves to hear the sound of my voice explaining math. Similar triangles is what we talked about, and we kind of made a little side note and talked about how the symbol that we've used for congruent looks like this, and congruent means same shape and same size. And I kind of look at it this way, where the equals means same size, but the tilde, the thing on top, or squiggle, I don't know what you want to call it, means same shape. Well, with similarity, we're only talking about the same shape. The size is going to be different. So the symbol for similarity is the little tilde thing. All right? And as we just said, similar means same shape, but this time the size is different. So keep in mind that these are same shape, different size, but the size is in proportion. So cereal boxes for different sizes of cereal, or lotion bottles, the little cute ones and then the bigger ones, they tend to be in proportion. And so that is what similar means. All right. A few vocabulary words. We have corresponding, and we have corresponding sides and corresponding angles. And what that basically means in not fancy words is that these are sides or angles that are in the same location. They kind of match up. All right, so the important part here is that when triangles are similar, their corresponding sides are proportional. And corresponding angles are actually congruent. And remember, congruent means same side, size, same shape. All right, this is important because this is generally what it means to be similar. Corresponding sides are proportional and corresponding angles are congruent. So on your paper, you want to make that look very important. Okay? And a little kicker that might help is just remembering what proportions are. And proportions are just ratios or fractions that we compare. So generally, a proportion is like a fraction equals a fraction. So a lot of the time I tell my students that when we're talking about similar triangles or figures, that it should pop in your mind when you see the word similar that you might need a proportion. Okay? So a lot of my students, I'll put up a similar problem and have them immediately just draw this. Sometimes we use it, sometimes we don't. All right. Whoa, I had a bubble in my throat. Another thing that you need to know is that we use this little thing called a similarity statement to tell us, once we know that these two triangles are similar, or however many, which parts are similar, which parts go together or correspond. So let's say we have triangle ABC is similar to triangle DEF. This is called the similarity statement. All right. And what it does really is it matches up the parts that go together. So see how we have A in this first position and D over here? Well, what that means is that angle A is congruent to angle D, because remember, corresponding angles are congruent when the triangles are similar. All right, and with that same kind of idea, we have angle B and angle E would be congruent. And likewise, angle C is congruent to angle F. All right, and that is the story for the angles when the triangles are similar. But the sides are proportional, and like I said, proportion means you're going to need to compare ratios. Ratios are fractions. And so since we actually have 3 sets, we're going to compare it 3 ways right now. All right. So looking at our letters, see we have side AB. So we have AB, and that's going to go with DE. All right, and I'm going to color code those for anybody that helps. If it doesn't help you, just enjoy my beautiful coloring. All right. Then side BC would go with EF. All right, so we're going to use the similarity statement to tell us which parts correspond, what goes together. And last we have AC and DF. They're in the same position in the similarity statement and therefore will be matched up to compare when we're looking at all the sides and angles. All right, so we're going to do 2 examples, one kind of more basic example and one example that involves more algebra. Okay, and this should be enough to get you started on your practice. If you have any questions after that, just, let me know. All right, so we're going to start with 2 different triangles. I want to change colors because I get bored. We're going to have this triangle, and we're going to have another one, and this one's a little bit bigger. Okay, and that's the thing. When we're talking about similar figures, we're going to have big ones and small ones every time we're comparing. Now, if you're just watching these to get a refresher, that's great. If you missed class, you actually should be writing these down because we're going to use them to be in your actual notebook. So I'm going to label some stuff in these. All right, so that would be information that we're given to begin with. And we're going to see if we can figure out X and Y. Well, Y is an angle, all right? And so we just need to look and say, all right, so which angle corresponds to angle C, since the Y is an angle C? Well, we're going to look up here at our similarity statement, and there's angle C. So that corresponds to angle F. So angle C and angle F have to be the same, but we don't know what angle F is, all right? But what we do know, and we haven't really discussed this yet, so it's going to be something I'm just kind of mentioning a few times until you solidify it, is that the angles in a triangle add up to 180 degrees. And so in order to figure out angle F, we need to add up, here, I'm going to put a little star there. We need to add up 48 and 97. So that would be 15, 145. Okay. These together add up to 145 degrees, and the whole triangle has 180 degrees, which means that angle F has to be 35 degrees. And since angle F corresponds to angle C, Y also has to be 35 degrees. All right, and just for fun, let's fill in our other angles. Angle A corresponds to angle D. So angle A is 48 degrees. Okay, and angle E corresponds to angle B. So angle B has to be 97 degrees. In similar triangles, corresponding angles are congruent. All right, now we want to figure out the measure of X. Sorry, what am I saying? So I'm actually going to highlight here the corresponding sides. That way we can pull them together. All right, here is our X. It's on side DF. So we need to look at our similarity statement, DF, and find the corresponding part for the smaller triangle, AC. Okay, so we're going to set up a proportion that's going to compare those. I'm going to go this time with the big on top and the small on the bottom. This means big triangle, small triangle. So our big triangle has X on top, and it has the small triangle on the bottom. We also have this side here that we know, and apparently I forgot to write what we knew on this side, right there. We have AB corresponding to DE. And again, we're going to make sure we're consistent. So since we have the big triangle on top, we're going to use the side of the big triangle, 8, and the corresponding side of the small triangle, 3. All right, now hopefully you remember from algebra that you cross multiply. So we have 8 times 12, which is 96, and x times 3, which is 3x. And at that point, you need to divide both sides by 3. So 32 equals x. So the length of this side of our triangle is 32. All right, we're going to do one more problem like that involves a little bit more algebra, and then this video is over. Okay, oops, I didn't want you guys to see that. I'm going to draw it over here. Actually, you know what? I'm not. I'm just going to cross that out instead of redrawing. You can redraw it if you want to. All right, so here is another example. I already highlighted the corresponding sides using my congruency statement. So here's the congruency statement for this problem. CD goes with FH, and CE goes with HG. So we're all highlighted. We don't want to look for angles in this problem. And I do want to point out that we cannot do the Pythagorean theorem in this problem because we're not looking for the missing side of this triangle, and even more importantly, because we don't know if this is a right triangle. And you can only use the Pythagorean theorem on right triangles. But we do know that we can set up a proportion. Okay? I'm looking at this with the small and then the big, so I'm going to go about it that way, small over big. And I'm just going to pick any part of the small that has a label. So here we have 21. So 21 on CE corresponds to this side we'd already highlighted, GH. So 21 over 9x plus 1 equals, and now we're going to go for our other part. Now we must put 24 on top because that's also part of the small triangle. And the corresponding part of the big triangle, 11x minus 1. All right, and now we're going to use algebra to cross multiply. Just remember that when you have a quantity like this on the bottom, it's best to kind of envision it in parentheses for forever, but for this part too. So we're going to do 24 times 9x plus 1. Those parentheses are important. Okay, and then the other direction, 21 times 11x minus 1. Okay, and you can see hopefully that we need to use the distributive property on each side of the equal sign. So we're going to have 216x plus 24 equals 231x minus 21. All right, from this point you have 4 things you could choose to do first. I'm going to choose to subtract 216x to get all of my x's together. And that equals 45x minus 21. Now we have all of our x's over here, so we're going to add 21. So we have 45 equals, you know what, I put the wrong number here. This is 15. I was just reading it and not actually doing it. 15x. All right, we're going to divide both sides by 15 to get the x alone. So x equals 3. Now, it would be awesome if we were finished, but if you look up here at the problem, it says find GH. So after we find x, we need to substitute in. We know that GH is 9x plus 1, and now we know that x is 3. So we're going to substitute the 3 in for the x. So we know that GH is 28 whatever units long. All right, So that's what we did. Those are the notes on similar triangles that involve algebra. I am going to upload this video into your notebook. So if you have already updated your notebook page, you may want to update it again if you want, but I'm also going to put the video under the classwork tab. So if you don't want to change, like if you've already done the work in the notebook, you don't need to update the page. It'll lose the work you already did. All right. Let me know if you have any questions. Have a great day.